Assalamualaikum and hi everyone. Before we start, I've always wondered, how does our phone actually connects to the internet without wires? Well, lucky for you, the answer lies in Wi-Fi and mobile signals, which use electromagnetic waves, especially radio waves, to send and receive information. Now, these signals operate at different frequencies. For example, Wi-Fi usually runs at 2.4 GHz or 5 GHz, while mobile networks like 4G or 5G use a range from megahertz to gigahertz. And behind the scenes, it all comes down to wave behaviors, like how waves travel, bounces off surfaces, or even bend around obstacles. So, to carry the information, these signals also use something called modulation. So even though we can't see these waves, they are constantly moving around us, helping our devices stay connected. Although, you also might be wondering, why did we choose this topic? Well, we chose this topic because it feels very close to us. All of us use Wi-Fi and mobile signals every single day. But we don't often think about how it actually works. We were really curious, how can invisible waves carry videos, music, or even live video calls? It also fits perfectly with what we learned in Physics 260. Things like wave speed, frequency, reflection, and interference are all part of how these signals work. So for us, it wasn't just interesting, it was also a great way to see how physics connects to real life.
Next, we have methodology. In this independent study, we combine structure, resource with hand-on exploration to understand how mobile signal work, from the router to the antenna, and finally to the phone. So here are some resources that we use. For example, Khan Academy and MIT OpenCourseware provide a solid foundation in physics and signal transmission concept. Other than that, IEE Spectrum offer up-to-date article and case study about wireless communication. Cannot forget, we also use textbook such as Software Physics, Generally Principle. And last but not least, we also use YouTube and signal visualization apps to see how signal behave in real life. Next, we move on to the learning method. Number 1, we have group discussion. We did a group discussion regularly to discuss about key topic in our topics. Next, we have real-life demonstration that we explore live signal tracking demands using smartphone app like NetMonster or SelfMapper. It helped us to revisualize how signal jump between tower and how signal strength varies in different area. Last but not least, signal flow breakdown. So the breakdown that process step by step from the router send data to telecommunication antenna. Then the antenna transmit radio wave through the air. And lastly, these signal are received and demonstrated by smartphone. So understanding this flow concept help us to guess how communication occur wisely in real life.
So right now, I'm going to talk about challenges and its solution. So the first thing I'm going to talk about is signal interference. The challenge for this is Wi-Fi and mobile signal can be interrupted by walls, other electronic devices, or even bad weather. The solution for this is use signal booster, better routers, or switch to less crowded frequencies like 5 GHz. The second is limited coverage. The challenge for this is in rural or remote areas, mobile and Wi-Fi signal may be weak or unavailable. The solution for this is build more cell towers, use satellite internet, or use mesh Wi-Fi system in homes. And the last thing I'm going to talk about is network congestion. The challenge for this is too many people using the network at once that can slow down the internet speed. And the solution for this is use or upgrade to 5G network and improve network infrastructure to handle more users.
Now, in this session, I'll be sharing with you guys the key physics concepts that help us understand how mobile signal actually work. So let's start with wave properties. The first one, we have the three main factors, which is frequency, amplitude, and wavelength. Frequency tells us how fast the wave oscillate, which is higher the frequency can carry more data, but they travel shorter in distance. Next, amplitude relates to the strength of the signal. The higher the amplitude, which is the stronger the signal, and wavelength affect how well the wave can pass through the building or bend around an obstacle. Next, we have a look on modulation technique. To carry information, the wave has to be changed or modulated. In all the system, we use AM and FM, but now more advanced methods like phase shift keying are used to transmit data by shifting the wave phase. This is how your phone knows what data is being sent or received. Then we have physical effects like reflection, diffraction, and diffraction. When a signal hits a building, it's reflected. Sometimes this is cause a signal to bounce and reach the phone from the different path. Refraction is when a wave bends as it moves through the layer like atmosphere, and diffraction helps wave bend around obstacle like turning a corner and still having signal. Now we have a look on key laws and theory that tie it all together. The first one, we have Maxwell equation. These are the backbone of electromagnetic theory, which is explain how changing electric and magnetic field wave create, like the one that used in wireless communication. Second is the inverse square law. This says that as you move away from your signal source, like a tower, the strength of the signal drops dramatically. This explains why you lose bar when you go far from the transmitter. Lastly, this interference and superposition. If two waves align perfectly, they can boost each other together. That is constructive interference. But if they cancel each other out, it's destructive interference, which causes signal loss or dead zone. So these are the explanation key physics concepts that we use.
So, for the real data example, in 2024, Malaysia internet penetration reached 97.4%, showing how widespread Wi-Fi and mobile signal have become. 5G adoption in cities like Kuala Lumpur or Johor Bahru improved download speeds by over 300% compared to 4G. So, for application, I have 4 here. The first one is communication. Video calls, social media, and messaging apps rely on Wi-Fi and mobile networks to keep people connected anywhere in the world. The second is education. Online classes and digital learning platform like Google Classroom or Zoom need stable internet signal to work well. The third one is business and work. Remote working emails and cloud storage system like Google Drive depend on strong and secure connection. And the last application is smart devices, smart TV, home assistant, and IoT devices use Wi-Fi to function and interact.
Let's move on to the advancement for Wi-Fi and mobile signals. First, Wi-Fi technology has improved a lot in recent years. The introduction of Wi-Fi 6 and Wi-Fi 6E has made the internet connections faster, more stable, and better at handling many devices at once. This is useful in homes, schools, and offices with lots of connected gadgets. An even newer version, Wi-Fi 7, is coming soon and promises to be much faster with very low lag, making it great for gaming and virtual reality. In general, these upgrades offer better speed and bandwidth, which means smoother streaming, faster downloads, and clearer video calls. For mobile signals, it also advanced, especially with the rollout of 5G. 5G is much faster than 4G and provides a strongest connection even in crowded places. One key feature is massive MIMO, which uses more antennas to improve the signal strength and support more users at the same time. Another improvement is network slicing, where one 5G network can be divided into smaller parts to handle different tasks like gaming, smart devices, or emergency services. There are many exciting careers related to Wi-Fi and mobile signal technology. First example is network engineer, who design and maintains wireless networks in homes, schools, and all businesses. Another is a telecommunication engineer, who works with mobile networks to improve signal strength and coverage. RF engineers focus on radio wave and signal transmission, while 5G and IoT specialists develop new ways to connect smart devices through faster networks. There are also security analysts who protect wireless systems from cyber attacks, and field technicians who set up antennas and maintain equipment. For those interested in innovation, careers in research and development allow professionals to create the next generation of Wi-Fi and mobile technologies.
To succeed in this field, a strong foundation in physics and mathematics is crucial. You'll often deal with concepts like electromagnetic waves, interference, and energy transfer, so being comfortable with formulas is a must. Another important area is wave mechanics and signal processing. Understanding how waves behave and how signals are transmitted, filtered, and analyzed. For more advanced simulations and testing, programming is essential. Languages like MATLAB and Python are commonly used in simulating networks and analyzing results. And finally, mastering practical tools like a spectrum analyzer or an RF signal generator helps bridge theory with real-world application, especially in labs or field testing situations. One of the biggest realities in this field is that technology moves fast. Right now, we're already talking about 6G and even quantum communication. That means professionals must continuously upgrade their knowledge. Some great ways to do this include enrolling in online certification courses, regularly reading new research papers, and attending industry conferences and seminars. These steps ensure we stay relevant and innovative in a rapidly evolving landscape. Of course, with such a dynamic field, there are challenges too. For example, the content can be very math-heavy and abstract. One way to deal with this is to take advantage of online courses and tutoring platforms that break down tough concepts into easier parts. Another challenge is by staying updated. To address this, setting a regular learning schedule, even just 15 to 30 minutes daily, can make a huge difference. And finally, many students struggle with gaining hands-on experience. Joining internships, tech clubs, or even doing hobby projects at home can help build your confidence and your resume.
To conclude everything, the advancement in mobile signals and Wi-Fi technologies have greatly improved the way we connect and communicate. Faster speed, lower latency, and better network performance have made our daily activities such as gaming, streaming, and video calling more reliable and efficient. Technologies like Wi-Fi 6, Wi-Fi 7, and 5G are shaping the future of smart homes, virtual reality, and even industries like healthcare and transportation. These developments also open up many career opportunities for those interested in working with networks, mobile systems, and wireless communication. As technology continues to grow, staying updated and skilled in this field will be more important than ever.
So here are our reference and citation for this topic.